Okay, so today's video is about follow-up questions to word problems, and really it starts out the same way we were doing stuff yesterday. You're going to have to write an equation, an exponential equation that models a word problem. After you do that, you're going to have to answer a follow-up question, something that comes after it at the end of the problem. So they're going to be a little longer than what they were yesterday. The last few days you've been identifying growth and decay, you've been writing. So there's not been something you had to do. You just read it through and you identify what's there. Today you're going to have to do something. Today we're going to do 3 read-throughs to a problem. And when we write them, we've been doing 2. The first time we read through it, we decide whether it's growth or decay. The second read-through, we identify our start and what we're doing, our A and our B. And then our third read-through today, we're going to actually answer that follow-up question. We're going to have to figure out the time period. Okay, and that should hopefully make a little bit more sense as we go through our problems today. So the steps. We're doing what we did previously. We write the equation first. So again, that's 2 read-throughs, a first read-through and a second read-through. And on that first read-through, we're deciding whether it's growth or decay. That helps us identify what our B value is in the second read-through. Okay, in the second read-through, we're identifying our start value, which is our A, and what we're doing, which is our B. Okay. Now remember, if it's growth, B is greater than 1. If it's decay, B is between 0 and 1. We've done a lot of work with that, so hopefully that idea is already in your head. That's our first 2 read-throughs. That's what we've done previously. Now, our third read-through today comes here when we're answering this question. You got to read your problem closely because what you're looking for is the time period. Okay? Time is the x. We plug it in for the x in our equation. All right? Now, there's 2 types to these, one where the time period's given, one where you have to do a little bit of work to figure out the time period. They are equally difficult. They're not that bad. But type 1 is easier than type 2 because there's less steps to it. But what we're doing is we're figuring out what we plug in for that x. So our third read-through, we're identifying our time period. Okay? All right, so we're going to start talking about type 1 where our time period is given. Okay, and I'll explain what that means here in a second. Typically on these problems, our time is in days or years. It does not have to be. It could be in hours, it could be in weeks, it could be in months, it could be anything, but typically it's in days and years, and that's given in the problem. Okay? We're going to do an example, and I think it'll make a little bit more sense. Okay? It says, I bought a rare coin in 1995 for $100. The value of the coin has tripled every year since then. How much is the coin worth in 5 years? So first thing I notice, I've got this question here at the end. That's the new piece to today. Okay? That was our first read-through. So for our first read-through, we should be able to identify that we're tripling every time. Okay? Tripling implies that our problem is growth, which means our B value needs to be greater than 1. And that's all we need to get through on the first read-through. Okay? Second read-through, we're identifying our start value and what we're doing. So I bought a rare coin in 1995 for $100. Okay? $100, that's my A. That's what I purchased it for. That's our start value. The value of the coin tripled every year since then. All right, so this tripled is my B. That means my B is 3. Tripling goes with multiplying by 3. And remember, that makes sense because this is a growth. It's getting bigger. 3 is greater than 1. That's what we want to see. We want to make that connection. All right, that's read through number 2. I'm going to go ahead and write my equation. Y equals 100 times 3 to the x power. Okay? Now, our third read-through, we want to identify that time period, and this is where the type 1 part makes sense. So, I bought a rare coin in 1995 for $100. The value of the coin has tripled every year since then. How much is the coin worth in 5 years? That is my time. That's going to be my x. Now, this is a type 1, and what I mean by type 1, if you see it says 5 years here, and in my problem over here it also says year. The time period matches. Time period matches. It is the same unit. I'm not saying it tripled every month and how much is it worth after 5 years. It triples every year. I want to know how much it is after 5 years. Those two units match each other. That's type 1. Okay? That makes it easy because now all I have to do for x is plug in 5. And then I take my calculator. I don't expect you to do this in your head, so don't try. Use a calculator. Okay, I take my calculator. I put it all in there in one step. I can do it all at once. I can do 100 times 3 to the 5th power. And I get 24,300. So that coin is now worth $24,300. And that's the answer to the problem. It's that easy. Now the reason again that this is type 1 is that our units match from the previous part, the part where we're getting our A, B, and whether it's growth or decay, to the question at the end. The units match. That's key. Because type 2, we have to determine that time period. Time periods don't match. Okay? You have to do a little bit of math to figure out what that time period would be. Okay? So here, when the time period in the problem does not match the one in the question, for example, like I said on the last one, I talked about this a little bit, it might be months in the first part of the problem, but then my question is in years. So I have to get these to be the same unit of measure, and that's what I'm looking at. Okay? Typically on this one, you'll see maybe days and years in the problem, but that's not what's going to match from question to the information part. So let's look at our example here. It says an initial rabbit population of 2 rabbits on a nature preserve, if left untouched, will double every 6 months. Okay. So first read through, I got to read the question still. How many rabbits are there in 5 years? First read through, double. This tells me that this problem is growth. It's getting bigger. Okay. Second read through, we're identifying A and B now. An initial rabbit population of 2. Okay, so there's my A. Rabbits on a nature preserve, if left untouched, will double, there's B, every 6 months. Alright, so let's write our problem. Y equals 2 times 2 to the x. B is 2 because doubling is really multiplying by 2. And that makes sense. We said it's growth. Growth has to be greater than 1. Okay, so now third read through. An initial rabbit population of 2 rabbits on a nature preserve, if left untouched, will double every 6 months. How many rabbits will there be in 5 years? So our time periods don't match. Okay, and this is where you have to do a little math. 5 years, 6 months. Well, 6 months is half of a year. That means that there are 2 6-month periods in a year. And we want to know 5 years. So I'm going to do 2 times 5 because there are 2 6-month chunks in 5 years. Well, 2 times 5 is 10. Okay, so my x value is now 10. I'm going to do 2 times 2 to the 10th power. And that's how I get my answer. So do you see how you had to do a little bit of math to figure out that time period? And this is where I think we're going to have trouble figuring out that time period on these ones that don't match. Because you do have to think a little bit. Okay, so now I'm going to take this and put it in the calculator. 2 times 2 to the 10th. And that gives us 2,048 rabbits. And there's our answer. It's that easy after we figure out that time period. Okay? So we got a few examples here now. I'm not going to tell you what type they are. We're going to have to decide when we read through it. Okay? So remember, we're doing 3 read-throughs on every problem. Example 1 here. You notice that there's mold on a piece of bread, but you decide to make it a science experiment rather than throw it away. You notice that you start with 1 square centimeter of mold and notice that it doubles every day. How much mold would you expect there to be on the bread at the end of 5 days? Okay? Well, I see doubles here. Doubles tells me that this is growth. That means B is greater than 1. Okay? Now, I'm not going to read all of this again. This part's not really important. I'm going to start here. You notice that you start with 1 square centimeter. So there's our A, 1. And that it doubles. There's our B. Our B is 2 every day. So our equation, y equals 1 times 2 to the x. Perfect. Third read through. Okay? It doubles every day. How much mold would you expect on the bread at the end of 5 days? Our time periods match. So this is really type 1. I don't have to do the extra step of figuring out the time periods. I just get to plug in a 5. Okay? I'm going to put it in my calculator. 1 times 2 to the 5th. And that is really 32. Okay, so my answer would be 32 square centimeters. Now, In Schoology, you're not going to have to worry about the label. I'm just looking for the number, so you type in 32. And that's how we do those problems. Okay, let's look at another one. James put 3 bacteria in a petri dish, and they double every 4 hours. How many bacteria are there after 2 days? Okay, so keyword here after the first read, doubles. This tells us that it's growth. B has to be greater than 1. James put 3 bacteria. Okay, there's our A value. They double. There's our B. So let's write our problem. Y equals 3 times 2 to the x. Now if I read it again, James put 3 bacteria in a petri dish and they double every 4 hours. How many bacteria are there at 2 days? Our time periods don't match. This is a type 2. Okay, so we got to figure out how many 4-hour chunks there are in 2 days. Okay, so we could write it out if we wanted. I know 4 hours. Okay, and then another 4 hours would be 8 and 12, 16, 20, 24. There are 24 hours in a day, so this is 1 day, and there's 1, 2, 3, 4, 5, 6. 6 4-hour periods in a day. I really want 2 days, so I'm going to take that 6 and I'm going to multiply it by 2. So that means there are 12 doubling periods in 2 days for this bacteria. So then 12 is my x. Y equals 3 times 2 to the 12th. And we take that now and we put it in our calculator. 3 times 2 to the 12th power, and we get 12,288 bacteria. Okay, and that would be our answer to the problem. Now in Schoology, you do not have to put the commas in, and again, you're not worrying about the label. Okay, so 12,288. So get one more here. When 4 foxes are introduced to the nature preserve, the rabbit population of 2,000 decreases by half every 3 months. How many rabbits are there left at the end of 1 year? Okay, keyword on the first read through, decreases. That tells us that this is decay, that B should be between 0 and 1. Second read through, 4 foxes are introduced to the nature preserve, the rabbit population of 2,000, that's what we're starting with. This is A, and I know that because my question says rabbits. I'm not talking about foxes. The fox population isn't getting more or less. It's staying the same. It's 4. Okay? Now, really in the real world, it's going to grow or not, but for the problem, fox population is not changing. The rabbit population is what we're talking about. Okay? And it decreases by half. That tells us that B is a half. Okay? So our equation, y equals 2,000 times 1/2 to the x. It does that every, this is our third read through, 3 months, and we want to know at the end of 1 year. If I notice, this is a type 2 because those time periods don't match. The units don't match. We want to know how many 3-month periods there are in 1 year. So let's write it out. 3 more would be 6, 9, 12. 12 would be 1 year. So there are 4 3-month periods in 1 year. I only need to do 1 year, so I'm not going to multiply by this by anything. It's just 4. So 2,000 times 1/2 to the 4th power. 2,000 times 0.5 to the 4th power, and I end up with 125 rabbits. And that would be our answer. Okay? I'm doing a little more of type 2 here just so that you guys get the practice of it, where you have to find how many time periods, chunks there are in that second time period, the one that matches the question. Okay? A little bit of a recap here because we're going to run out of time. In the same process, what we're doing is what we've already done. It's what we did the other day. You're going to write an equation to model. Okay? Today, x is time. So our first 2 read-throughs, okay, remember this is where we get growth or decay. This is where we identify A and B. On our third read-through is where we identify time. You need to make sure that you're reading it closely, so if you determine that the time matches or doesn't match, is it type 1 or type 2, and then plug that in for x and solve. If you have any questions, be sure to post them to the discussion board or shoot me an email, and good luck on your Schoology assignment.